We are going to look at some number sequences and write general rules for them in each case. Here are three sequences. You're probably familiar with them. They're the 2 times table, the 3 times table and the 5 times table. These are called arithmetic progressions. To get to the next number in the sequence, you add the same amount. So for the 2 times table, you're adding 2 each time. For the 3 times table, you're adding 3 each time. And for the 5 times table, you're adding 5 each time. We're going to write a rule for each sequence and use these rules to help us find rules for other arithmetic progressions. Let's begin with the 2 times table. We have the numbers 2, 4, 6, 8, 10, 12, 14 and so on. These numbers are the terms of the sequence. And to find the rule, we are going to find the nth term of this sequence. I'll explain what I mean. I'm going to make a table and I'm going to put the terms in that table. And I'm going to number each of those terms. The first term in our sequence is 2, the second term in our sequence is 4, and so on. There is a relationship between the pattern number and the term. So the first term is 1 multiplied by 2. The second term is 2 multiplied by 2. The third term is 3 multiplied by 2. The fourth term is 4 multiplied by 2. And this makes sense, doesn't it? Because this is the 2 times table. So if I want to write a general rule for a sequence, we call that the nth term, where n can be any number. So the nth number in the sequence is going to be n multiplied by 2, which is 2n. And there is our rule. And so we can use this rule to find any term in a sequence. If I wanted to find the 12th term in the sequence, n would equal 12. And so the 12th term would be 12 multiplied by 2, which is equal to 24. And if I wanted to find the 23rd term in the sequence, well, n would be 23. And so the 23rd term would be 23 multiplied by 2, which is equal to 46. Now let's look at the 3 times table. We'll approach it in exactly the same way. So here's a table. Here are the terms, 3, 6, 9, 12, 15 and so on. And we're going to number the terms of our sequence, 1, 2, 3, 4, 5, 6, 7. So if we look at the first term of our sequence, if we multiply the pattern number by 3, we get 1 multiplied by 3, which is equal to 3. The second term would be 2 multiplied by 3, which is equal to 6. The third term would be 3 multiplied by 3, which is equal to 9. The fourth term would be 4 multiplied by 3, which is equal to 12. And the fifth term would be 5 multiplied by 3, which is equal to 15. Our nth term would be n multiplied by 3, which is equal to 3n. And if I wanted to find the 12th term of this sequence, well, n would equal 12. And so the 12th term would be 12 multiplied by 3, which is equal to 36. If I wanted to find the 25th term of this sequence, well, n would equal 25. And so the 25th term is 25 multiplied by 3, which is equal to 75. So the general rule for the 2 times table is 2n. The general rule for the 3 times table is 3n. You could probably guess what the rule will be for the 5 times table. And of course, the answer to that is 5n. And so for any multiplication table, we can quickly write down the rule. For the 1 times table, it would be n. For the 4 times table, it would be 4n. For the 10 times table, it would be 10n. And we can use this to help us find rules for other arithmetic progressions. Here are some arithmetic progressions. We can see that in each case, that to get to the next number in the sequence, you add 2 each time. I'm immediately thinking of the 2 times table. So we're going to use the 2 times table to help us find the general rules for these 3 sequences. In each case, I'm going to use a table. I'm going to write down the pattern number 1, 2, 3, 4, 5, 6, 7, and so on, all the way up to n. Here's our 2 times table, 2, 4, 6, 8, 10, 12, 14, all the way up to 2n. And here's our sequence, 1, 3, 5, 7, 9, 11, 13, and so on. I want to use the 2 times table to help me write down the general rule for this sequence. So how do I get from the 2 times table to the sequence that I'm trying to find the rule for? Well, if we look at the first term, to get from 2 to 1, I subtract 1. Looking at the second term in the sequence, to get from 4 to 3, I subtract 1. For the third term, to get from 6 to 5, I subtract 1. From 8 to 7, I subtract 1. From 10 to 9, I subtract 1, and so on. So by comparing the 2 times table to our sequence, for each term, we are subtracting 1 to get from the 2 times table to the sequence. If we get to our nth term, which is 2n, for the sequence, it would be 2n subtract 1. So the 10th term of this sequence would be 2 multiplied by 10 subtract 1, which is equal to 19. And the 50th term of this sequence would be 2 multiplied by 50 subtract 1, which is equal to 99. Let's do the same for the other 2 sequences. So here's the pattern number, 1, 2, 3, 4, 5, 6, 7. There's the 2 times table. And here's the sequence. How do I get from the 2 times table to our sequence? Well, we can see in each case that we're adding 1 this time. 2 add 1 is equal to 3. 4 add 1 is equal to 5. 6 add 1 is equal to 7. So the nth term of our sequence is 2n add 1. Have a go at the last sequence. What's the nth term? So we can see that in each case, to get from the 2 times table to our sequence, we're having to subtract 7. 2 subtract 7 is equal to minus 5. 4 subtract 7 is equal to minus 3. 6 subtract 7 is equal to minus 1. And so, for our nth term, is going to be 2n subtract 7. So that's the nth term of this sequence. Here are 3 more sequences. In this case, for each sequence we're adding 3 each time. So I'm thinking of the 3 times table. I'm going to apply the same approach as I did for the other sequences to find the general rules for these 3 sequences. You might want to have a go at this yourself, so feel free to pause the video, and when you have found the rules, press play to get the answers. So for each sequence, I'm going to put this out in a table. Here is the pattern number, here's the 3 times table, and here's the sequence. So I need to work out how to get from the 3 times table to the sequence for each term. So to get from 3 to 1, I had to subtract 2. To get from 6 to 4, I subtract 2. To get from 9 to 7, I subtract 2. So for the nth term, to get from the 3 times table, which is 3n, I'm going to subtract 2. And so the nth term of this sequence is 3n subtract 2. For the next sequence, here's the pattern number, here's the 3 times table, and here's the sequence. We can see that to get from the 3 times table to the sequence for each term, this time we're adding 2. So the nth term is going to be 3n add 2. And for the next sequence, we can see that in each case we're subtracting 5. 3 subtract 5 is equal to minus 2. 6 subtract 5 is equal to 1, and so on. So our nth term is going to be 3n subtract 5. Here are 3 more arithmetic progressions. Have a go at finding the general rule for each of these progressions. So pause the video, and when you're ready, press play. So you probably noticed that for each of these progressions we are adding 5 each time. So you should be thinking of the 5 times table. So in each case, let's compare the sequence to the 5 times table. Here's the first one, and we can see that to get from the 5 times table to the sequence, we're subtracting 3. 5 subtract 3 is equal to 2, 10 subtract 3 is equal to 7, 15 subtract 3 is equal to 12, and so on. So the nth term of this sequence is going to be 5n subtract 3. For the next sequence, to get from the 5 times table to the sequence, we're having to add 1. 5 add 1 is equal to 6, 10 add 1 is equal to 11, and so on. So the nth term is going to be 5n add 1. And for the final sequence, we are subtracting 6 each time. 5 subtract 6 is equal to -1, 10 subtract 6 is equal to 4, 15 subtract 6 is equal to 9. So our nth term is going to be 5n subtract 6. So for arithmetic progressions, think about the multiplication tables. If we look at this sequence here as an example, 1, 5, 9, 13, 17, 21, 25, we are adding 4 each time to make the next number in the sequence. So I'm thinking of the 4 times table, which means it's going to be 4n add or subtract something. Well, here's the 4 times table, and to get from the 4 times table to our number sequence, we're subtracting 3 each time. 4 subtract 3 is equal to 1, 8 subtract 3 is equal to 5, 12 subtract 3 is equal to 9, and so on. So our general rule for this sequence is going to be 4n subtract 3. And for this sequence, 2, 3, 4, 5, 6, 7, 8, we're going up 1 each time, so I'm thinking of the 1 times table. So the nth term is going to be n. And we can see that to get from our 1 times table to our sequence, we're adding 1 each time. 1 add 1 is equal to 2, 2 add 1 is equal to 3, 3 add 1 is equal to 4. And so our nth term is going to be n add 1. So there's a quick look at arithmetic progressions. I'm going to be doing some more work on sequences in the following videos. But I hope you found this video helpful, and thank you for watching.